video we're going to talk about taking groundwater samples and the methods around taking groundwater samples. So as part of groundwater sampling, we'll talk about well purging, sample collection, filtration, and we'll touch briefly on preservation. So when we're taking a groundwater sample, we typically want to sample from the aquifer, not from the well. And so we do something called purging. So in order to purge a well, we're going to pump water out of a well and allow water from the aquifer to move into the well. The only time when we're not going to want to do this really is when we're looking for very volatile compounds, because that pumping and purging process is going to volatilize all those compounds. And if we're focusing on those, then we may want to take a sample before purging. So the standard method for purging a well is to remove 3 times the amount of water as the volume of the bore. And so we can measure the depth to water and the depth of the well and the diameter of the well casing. And from that we can calculate the volume of water that's in that well. So the standard method would be to remove 3 times that amount of water by pumping, let it recharge, and then take a sample. Practically, what we often do, which is also meets our standard methods, is to remove water until the pH, conductivity, and temperature have stabilized. So this allows us to sometimes remove less water, or if we're removing water at an unknown flow rate, it lets us use the temperature and the conductivity and the pH as a mechanism to see whether everything's stabilized and whether we've stabilized to the water that we're assuming is coming from the aquifer. Here is the equation for calculating the volume of water in the well. This is just the volume of a cylinder, essentially. So when we purge a well, typically we'll use a pump. You can purge a well using a baler. That's what's in this picture. But it would take you a very, very long time. But sometimes if that's the only equipment you have, that's what you'll use. We also will measure the water level. So these are just 2 pictures of water level indicators. This is the kind that we'll use in class. With a water level indicator, typically you'll lower it down, and there's an electrical circuit that's closed when it hits the water, and it'll make a loud beeping noise. And that's when you'll know that it's hit the water. You can then turn off that sound indicator and drop the weight on the end here down to the bottom of the wellbore until you feel it hit the bottom. And so by doing that, you can measure both the depth of the well and the depth to water. There are some places, and Athens County is one of them, where if you tried to purge 3 times the wellbore, you would dewater that well, and there would be no more water left in that. And so where you have a low flow aquifer, where you have a low hydraulic conductivity aquifer, you may have to use a low flow purging method. And so with a low flow purging method, you'll extract water, you'll still pump water out, but at a low flow rate, so ideally similar to the recharge rate of that well. And then the sample is then taken, so you'll pump at this low slow method, or low slow level, and then when you take your sample, you try not to take from the top of the well, you try to take your sample from further down in the well. So there are weighted balers and things like that can be used to ensure that. So when we take a sample, our samples can either be taken by a baler or a pump, and I'll show you what a baler is in class. So for shallow or narrow bores, a baler may be a better option. But there are different options for the material and for the tip. So in terms of the material, there are stainless steel reusable ones that can be cleaned between sites, and there are disposable plastic ones. There are also reusable plastic ones, but the reusable plastic ones shouldn't be used in applications where you're sampling for organic materials. In terms of the tip, there are low flow tips that can be used for when you're sampling for a volatile organic compound that limits the agitation of the sample when you fill your sample bottle, and should retain the volatile organic compounds in the sample. You can also use a pump to take a sample, but a lot of care has to be taken to make sure that you don't aerate the sample through pumping. Wells that are plumbed, where you're already where it's plumbed to somebody's spigot or to their house, you can use that plumbed well and you just run it. You run the water until the temperature and the conductivity and the pH have stabilized, and then you can reduce the flow rate right down so it's just flowing very smoothly and with laminar flow, so you don't have very much aeration, and then you can take a sample. It's really important if you're using somebody's sink to take a sample that you remove the aerator off the sink. So just like with surface water, field parameters, so temperature, pH, specific conductivity, dissolved oxygen or oxidation reduction potential, and total dissolved solids should be taken at the time of collection, and this should be taken after purging and stabilization. Just like surface water samples, we have to choose whether to filter or not. I've shown different photos of different filtration apparatus. So oftentimes we'll use syringe tip filters that are attached to a syringe, and then there are multiple different options for vacuum pump filter setups. These are cartridge filters that can be used similarly to a syringe tip filter. So with groundwater, we often have fewer sediments and solids than we do in surface water, but you may disturb or pick up different things from the wellbore. And so depending on the purpose of your sampling, you may want to filter these samples as well. So we're going to quickly talk through the sample container preparation and preservation for different parameters. If you want more information, feel free to pause this video and look more at these tables. There's a lot of information in them. So I've got this broken out by analyte, container, preparation, and preservation. And this is important not just for groundwater, but also for surface water. And so here on this page we can see anions, cations, arsenic, selenium, mercury, and trace metals. And so depending on what analyte we're looking for, we'll use a different type of bottle. All of these want to be filtered. In surface water, we'll often do a total and a filtered sample, but in groundwater, often it's recommended that you filter. And then we use different preservation techniques for each of these. So similarly, this is that same information for dissolved organic carbon, nutrients. We've got arsenic, selenium, and mercury in here twice apparently, fluoride and iodide, and gold. Isotopes in water, we're not really going to cover those in class, but if these are interesting to you, or if you ever have to sample them, these are some very basic details. Dissolved gases, it's very, very important to fill to the brim fully, so that you have no air, and no air can leak into your container. Radioactive isotopes have very specific sampling procedures. Again, we won't cover those in this class in any more detail than this. And same with chlorine. They have very specific sampling procedures. So this is just a very brief overview of how to take samples, filter them, and preserve them. This is only to serve as an introduction, and we'll talk more about these in class. Thank you for listening.